Hello everyone, this is Heting Tian. In this video, let's learn 3.2 polynomial functions and their graphs. Polynomial functions are continuous functions. They are continuous graph. Let's look at the first two graphs. They are continuous and they have smooth rounded corner like this. They are smooth or rounded corner. And if the graph like the third and fourth graph, they are not the polynomial function because we see the jump, they are not continuous. And also they have the sharp corner. They are not continuous function. How to graph the function? First, let's decide the behavior of two sides. What's the meaning of behaviors? So look at the graph, the second graph here. The left and the right end. The right end, we say, is on the right, is all the way going up. And then the left end is on the left, is all the way going up. Let's decide how to find the right side and left side going up or down. First, we need to learn what is the degree of the polynomial. I think we have this before in previous lessons, but let me remind you. If f of x equals positive x to the fourth plus 3x plus 4, this is a polynomial function. And the degree of the function is depends on what is the power of the x in the leading term. So this leading term, we only have the x to the fourth. The x power is 4, so the degree is 4. Okay, let's see. And also the behavior depends on positive and negative leading term. So here is positive, and we will use this information to decide the behavior. How to decide? First step, if the leading coefficient is positive, the right end of the graph will rising. Okay, let's see this one. Yes, it's positive because the example, we have positive leading coefficient. So the right end is rising. The right end, so let's put the right here, is going up. Number 2, if the leading coefficient is negative, the right end of the graph will be falling. So let's create another function, f of x equals negative, for example, 20x to the cubed plus 2x minus 3. So we have negative leading term. The right end is going down. When the right end going up or going down, what's the meaning of that? If the x is approaching infinity, because this represents x approaching infinity, the y's value is approaching infinity. The second function, the right end, x approaches past infinity, y is going all the way down, approaches negative infinity. Let me make better looking behavior going up. The number 3, if the degree of the polynomial is even, the left end will have the same behavior as the right end. Okay, we are deciding the left end. Now the first graph, the first function, they have the degree 4. 4 is even. Even means the same behavior. Okay. So the right end is going up, then the left end has the same behavior, also going up. And let's see, number 4, if the degree of the polynomial is odd, then the left end will have the opposite behavior as the right end. Okay, let's see. We are lucky we built the degree, second function degree is 3, that's odd. So the degree is odd. Odd means different behavior, opposite different behavior. So the right is going down, then the left is going up. It's opposite like another side. Okay, let's use these to decide. Look at the example. First example is a function f of x equals x cubed plus 3x squared minus x minus 3. So first decide the right end. Here is 1, that means positive leading term. Positive means going up. You see, a right end going up. And second, decide the left end. All depends on the all depends on the degree. Degree is odd. Odd means opposite. So opposite means going down. So false on the left. Next example, f of x equals negative x to the fourth, blah, blah, blah. So the rest of them, I don't need to worry because the left and the right end only focus on the leading term. So leading coefficient negative. We have negative sign here. Then the right end going down. Look at the power is 4. That's even. Even means the same. So if the right end is going down, the left end is also false left, going down. Okay, let's see the examples here. Use the leading coefficient, determine the end behavior. Let's see the first function, f of x equals negative x cubed minus x squared plus 5x minus 3. First, decide the right end. The right end negative means going down. Let me use different color. And then the power of the leading term is 3. That's odd. Odd means different or opposite. So the left is going up. As the x approaches infinity, that means the right end. Y is approaches negative infinity because it's all the way going down. As the x approaches negative infinity, that's the left end. Y approaches infinity. Number 21, f of x equals 5x to the fourth plus 7x squared minus x plus 9. First, decide positive or negative leading term. Leading term positive, that means the right end going up. Second, the degree is 4. That means is even. Even means same. So they have the same behavior. Point to the ceiling. So as the x approaches positive infinity, y approaches to the ceiling. That's the infinity. As the x approaches negative infinity, y approaches infinity. Okay, let's move on to see the zeros. Oh, my pen. Zeros means x-intercepts of polynomial function. To find zeros of polynomial function, set the function equal to 0. Second, factor the polynomial. Last, use the zero factor property to find the solution. So for example, if I have f of x equals x squared plus, for example, 2x minus 3. Then we can use AC method or AM method to factor this one. So make it equal to 0 and factor this for polynomial. So that's the x plus 3 x minus 1 equal to 0, and use the zero factor property find the solution. So the first factor equal to 0, second factor is 0, x plus 3 is 0, x minus 1 equal to 0, can find x equals negative 3, x equals positive 1. So these two, they are the x-intercept of the function. Let me clear all of this. It's so messy here. Then decide multiplicity of x-intercept. What is the multiplicity? If after factoring my function, we will have this in the function. For example, I have f of x equals x minus a to the k's power. Then we can solve, make the function equal to 0, solve for the x. So the x equal to 0, because only 0 to the k's power can be 0. So x minus 1 is 0. Oh, sorry. X minus a is 0. X minus a equal to 0. X equals a. So we found the 0. but 0 is a repeated 0 because it has the power k. So we could have x equal to 0, x equal to 0, x equal to 0. We call the power is multiplicity k. If k is odd, for example, is 1, 3, 5, the graph crosses the x-axis at x equals a. Oh, at x, this is x-axis, this is a. Then at this point, when the graph crosses the a, if the k is even, the graph touch the x-axis at x equals a and turn around. For example, if I have the a here, then the graph touch and bounce off at the x equals a. Let's see the example. If I have the function f of x, this is a factored form. They factor the expression for us. And then we can find the first factor equal to 0, second equal to 0. We can solve for the x equals -1, all of this part equal to 0, all of this part equal to 0. X equals positive 3 over 2. Then we can plot the point here and here. First point is -1, another point is 3 over 2. Then we mentioned that if multiplicity, if the power here is odd, then cross this point. You see, okay, cross this point. If the power is even, or we say multiplicity k is even, it touch and bounce off. Okay, let's see the graph here. From the given graphs, determine the zeros and their multiplicities. Zeros means x-intercepts. We have two x-intercepts here. So first x-intercept, x equals -2. And second x-intercept, x equals +4. Let's decide that their multiplicities, k. The k for the first point we see is cross -2. That means k must be an odd function, odd number. So k could be 1, also could be 3. But you see this straight line without any curve in or curve out, k is 1. If we have this, here, okay, let me erase this. Yes, looks good. So we have this curve in, curve out. Maybe the k is 3 or 6, or 5. And x equals 4 here. Curve in, curve out. So k equals 3. Okay, let's see next one. Number B. It has 3 zeros or 3 x-intercepts. They are x equals -2, x equals 1, x equals 4. So we put x equals -2, x equals +1, x equals +4. Then what is multiplicity, or what is the k? K for the first one is go cross it and without any curve. That means k equals 1. And the point x equals 1 touch and bounce off. The k equals 2. And the last point, x equals 4, touch and bounce off, k equals 2. Because because here is touch and bounce off, the k must be an even number. And here k is even number. K here is odd number. Okay, things more clear. Okay, let's find the zeros for each polynomial function and give the multiplicity for each zeros. Okay, they are not factored form. Then we need to factor the function. So first step, let the function equal to 0. X cubed plus 7x squared minus 9x minus 63 equal to 0. How to factor this? 4 terms. 4 terms, we do the group factoring. First 2, last 2 terms. First 2 terms, I can factor out the x squared, sorry. Then the leftover is x plus 7. last two terms. We have -9, we have -67. So the GCF is -9. I can factor out the -9. Then in the parentheses, we have x plus 7 equals 0. Then we factor out the GCF x plus 7. The leftover is x squared minus 9 equals 0. We're not done because the second part is the conjugate formula. X plus 7. X squared minus 3 squared. Is that a squared minus b squared? Yes. So that's x plus 7 times x plus 3 times x minus 3. Then let's solve for the x. Need more space. So we have three equations. X plus 7 equals 0. X plus 3 equal to 0. X plus, minus 3 equal to 0. If I solve all of these three equations, x equals -7. X equals -3. X equals +3. Let's decide their multiplicities. So for the power of 3 factors, here's 1, here's 1, here's 1. So the k, the multiplicity of them is 1, 1, and 1. That means at the point at x equals -7, the graph go cross and go cross and go cross at these 3 points. Okay, let's see next example. F of x equals x to the 5th minus 14x to the 4th plus 49x cubed. This one, we have 3 terms. Leading term is 5, x to the 5th. That means I can factor out the GCF first. The GCF here is x to the 5th, x to the 4th, x to the cubed. GCF x is x cubed. So factor out x cubed. We have x squared minus 14x plus 49. This is the perfect square. You can see from x squared minus, so a squared minus 2ab plus b squared. You can find the perfect square, or you use AM method. You factor this one. We must have x cubed times x minus 7 squared. So if you don't know how to use ACAM method or perfect square method, factor this one. So go back to the chapter 1, find how to use the method, factor the polynomial. Okay, let's decide. Make this one equal to 0, because first step we should say all of them equal to 0. Then we have 2 factors. Each factor has its multiplicity. Okay, so first factor I can say x cubed equal to 0. Second factor x minus 7 squared equal to 0. Solve them. X equal to 0, and second part x minus 7 equal to 0. Then let's see, the second part is not solved. X equals 7, we can add 7 both sides. For the x equal to 0, what is the multiplicity? It's 3, so the k is 3. And then second one, k is 2. If the k is 3, so it's the odd number. That means we have the graph go cross it, but it's curve in and curve outside. So we're having this. And the second one, k is 2, that's even. That means touch and bounce off. We're having touch and bounce off graph. Okay, let's see next part, even function and odd function. If a graph of function is symmetric with respect to the y-axis, we say that it's an even function. That's for each x in the domain of f of x equals f of negative x. For example, For example, f of x equals x squared. This is an even function because the graph is symmetrical along the y-axis, for example. So the y-axis is like a mirror. Both sides of the mirror, they are the same. Why I'm doing this? Okay. So for example, I plug in the x value. This is positive x. Then the y's value output is here. If I input a negative x, then they have the same y's value. That's the reason if it's an even function, we are having f of x, the input is positive x, and also have the same value as y's value as the input negative x. Let's see another one, the odd function. Clear this. If the graph of the function is symmetrical with respect to the origin, 180-degree rotation, we say that is an odd function. That is for each x in the domain of f. F of negative x equals negative f of x. For example, in previous lessons, we have learned that f of x equals x cubed. This is the odd function. The graph of this one is, pass through the origin. If I rotate 180-degree, we will have the same graph like this. So if I rotate, I don't know. So if I rotate the clockwise 180-degree, I'm having the same graph, so overlapped with each other. And they must satisfy f of negative x equals negative f of x. That means if I have an input, for example, my input is x, the y's value is here. If the input is negative x, then its output value, for example, here is 5. The opposite is the output value is negative of 5. So here must be negative 5. Okay. That means if so let me say this. If the input is positive 5 and I have a value like I put a triangle here, then if the function is odd function, the input is negative x, negative 5, then the output is negative a triangle. Okay, let's decide if these graphs, they are even, odd, or neither. The first graph, we don't need to do any test, is even function because it's symmetrical along the y-axis. We can put even here. Or you say, can I do the test? Because you said this, we need to use a test. So if the input is at 2, the y's value is 3. If the input is negative 2, the y's value is also positive 3. They are the same. So this is even function. Next one, is this even or odd or neither? So you say, you said odd function, I can rotate 180-degree, and then they have the same graph. But I don't know how to rotate on my screen or on my paper. So I can use the test here. So I can use the test here. So I find an input, for example, let's see, what is f of 1? F of 1 is, let's say, is a point here. It's about 1.8. And then let's find what is f of negative 1. Let's put it in negative input. It's higher than 2. So it's about 2.2. Are they the same? No, they are not same. That means they are not even function. Are they opposite? One negative, one positive? No, so neither. Let's see, next one. Is this graph the even function? Of course not, because it's not symmetrical along the y-axis. Is this an odd function? Let's test. Let's pick some easy point. I think 3 is better because I can find y's value easily. So f of 3 is 4. How about f of -3? Input -3, and output is -4. Yay, this is odd function. Because you see, if I put the negative input, I have -4. If I make a positive input, I got +4. So to satisfy this condition, this is odd function. So if you're smart, you can rotate clockwise or counterclockwise 180 degree. You got the same graph. Let's see next one. This one is not even function because it's not symmetrical along the y-axis. Is this even? Let's test. When we are doing the test, we can plug in the f of, let's choose a point. Let's choose 3 because, so 3 can be easily find the y's value. We have 1 as y's value. And how about -3? F of -3. Oh, I can't find it because all the way going up. So for example, if I can find it is positive 100. And then are they the same? Different. And are they opposite? No, they are not opposite. They are both positive. That means neither. Okay, let's see this one. This one must be even function because it's symmetric along the y-axis. Y-axis is like a mirror. Both sides, they are the same. You can also do the test. F of 1, is that equal to f of -1? Okay, f of 1 equals 1. F of -1 is also 1. Yes, they are the same. So that's an even function. Let's see. Take a guess. This is even or odd? This is interesting. It's not even, right? It's not symmetrical along the y-axis. Can I say that's odd? Let's take a test. So let's choose some point. If I choose a point, for example, can I choose 1.5? So maybe the y's value can be found easily. So f of 1.5. The y's value is 1. Let's try what is f of -1.5. The -1.5, okay, -1, yay. Input positive, output positive. Input -1.5, output is -1. The x, they are opposite, and the y, they are also opposite. Yay. So this is even, this is odd function. We put odd here. Let's see, determine whether each function is even or odd. Let's see, first one. If we don't have a graph, we just plug in the f of -x. If equal to the function f of x, that's even. If opposite sign of the f of x, that's odd. If satisfies none of these two conditions, that's neither. Okay, input -x cubed plus -x. Simplify the expression. So base is negative and the cubed, that is -x cubed. So if you don't remember how to do this, you can do -x times -x times -x. Must be -x cubed. Then minus x. Let's see. This is negative. This is negative. Here is positive. Here is positive. Oh, I see. This one equals negative f of x. If equals -x, let's see. Input negative, output negative, input positive. They have positive solution. Okay, this is odd function. Let's see, next one. Let's give a negative input, negative x equals negative x squared plus negative x. Simplify the expression. We have x squared minus x. This one and the g of x, are they the same? No, not even. Are they opposite sign? No, they are not. So this is neither. Next one, let's put input negative x. So negative x squared minus negative x to the fourth plus 1. Then negative x squared, that's positive x squared, minus negative x to the fourth plus 1. Are they the same? Even my handwriting and the printed the font, they look different, but they are the same thing. That means this is the even function. We put even here. Okay, we learned a lot about the polynomial function. Let's graph the polynomial function. Graphing a polynomial function, we need to follow the 4 steps. So here, no graphing calculator. So graph by your hand. So first, use the leading coefficient test. Determine the graph and behavior. Do you still remember that? Left and right and behavior. Second, find the x-intercept. Set the function equal to 0. Find the x value. And find the multiplicity of each x-intercept. Find the k. Number C, determine whether the graph has y-axis symmetry. Find the even or odd of the function. Number D, if necessary, find a few additional points of the function. Okay, first, let's see the behavior of both sides. Leading coefficient positive, that means we have the going up right end, and we have the degree of the function is 3. That's odd. We have different behavior on the left. Okay, let's answer the part A. As the x approaches infinity, y approaches infinity because it's always going up. As the x approaches negative infinity, on the right left end, y approaches negative infinity. Okay, let's see x-intercepts. That cross, that touch. Let's find what is the x-intercept. First, we can let the function equal to 0. X cubed minus 3x squared minus x plus 3 equal to 0. We have 4 terms. We do the group factoring. First 2, last 2, x squared, x minus 3. Last 2, we can factor out negative 1. X minus 3 equals 0. X minus 3 times x squared minus 1. We cannot leave the function like this because the second part of the expression is the conjugate formula. X squared minus 1, that's x squared minus 1 squared. Even there's no squared here, but you must know that's 1 squared. Then the second part is x plus 1 times x minus 1 equals 0. Solve for the x. First equation, x minus 3 equal to 0. X plus 1 is equal to 0. X minus 1 is equal to 0. Solve for the x. Add 3 both sides. X equals 3. Then subtract 1 both sides. X equals negative 1. X equals positive 1. Decide the multiplicity of these 3 points. Multiplicity means the power. Power here is 1. Power here is 1. Power here is 1. So the multiplicity k equals 1. K is 1. K is 1. That means at the point here, they all go cross, because k is odd number. So x intercept at that cross. So these 3 points all crosses the x-axis. So we list them in the set. 3, -1, 1. Or if you want to have the order -1, 1, 3, it's totally fine. There's no touch. So next, let's decide the even or odd. So let's say first that we decide the behavior of both sides. Second, we find the x-intercept. Third, let's decide even or odd of the function. Let's try to find what is f of -x. We plug it in the function. -x cubed minus 3 minus 3 times -x squared minus -x plus 3 is -x cubed negative base, and the cubed power is 3. Power is odd, so we must have negative solution. Negative x cubed minus minus 3x squared, because the power is squared, plus x plus 3. So tell me, this is even or odd? If it's not equal to f of x, this is not even. And can I prove that equals negative f of x if it's odd function? No, because if here I have a negative, then everything, they have the opposite sign of the f of x. So here is negative, second term negative, but here is negative. They are not opposite. That means neither even or odd is not symmetrical along the y-axis or the origin. So neither. Okay, we can plot the information. I think the graph here, I have no space. So let me put the information here. I should make my my notes smaller. Okay, let's find the x-intercepts. The 3 x-intercepts, they are -1, 1, and +3. Then the two-side behavior, let's see the graph. We decided from here. Okay, we can put going up and going down, right? Yes. At the point 1, -1, 1, and 3, they are all touch and go cross, go cross, go cross, go cross. But I think it's not that accurate, because if I could find a point between these 3 key points, I can graph more accurately. So let's first find some point between -1, +1, 1, and 3. Let's put the notes here. So can I say number 4? Okay. Let's say f of 0, because 0 is between -1 and 1. Put it in the function is 0 cubed minus 3, 0 cubed, 0 squared, sorry, minus 0 plus 3. Why my notes is not very pretty. 0 cubed minus 3, 0 squared minus 0 plus 3. Here is multiplication. So 0, 0, 0 plus 3 is 3. So the point is 0, 3. How about f of a point between 1 and 3? Let's put 2. Then plug it in the function. 2 cubed minus 3 times 2 squared minus 2 plus 3. What is that? That's 8 minus 3 times 4, 12, minus 2 plus 3. What are we going to have? -4, -6 plus 3, -3. Second key point, I could have 2, -3. Then plot them on the graph. 0, 3, 0, 3. Let's see, the point is here. 2, -3. 2, -3. This is 2, let's say this point is -3. Then we are connect all the points. We are having the graph like this. Assume that I have the correct graph, because sometimes it's not that accurate. Graph a new one. And all the corner must be smooth, because this is a polynomial. All right, let's move on to next part. This time I will write something smaller, then we have enough space. As x approaches so first step, let's decide the behavior on both sides. Positive leading term, that means the right end is going up, and then the power is 4. That's even. They have the same behavior on the left. Second step, find the x-intercept. Before that, let's fill out the blanks here. As the x approaches infinity, the y approaches infinity because it's going up. As the x approaches -infinity, x approaches infinity, because they all have the same behavior going up. Let's find the x-intercept. Set all the function equal to 0, x to the 4th minus 9x squared equals 0, and factor out the x squared. We have x squared minus 3. Oh, sorry, 9. That's 3 squared equals 0. X squared times the second factor, that's conjugate formula. That's x plus 3, x minus 3. So if you don't remember the conjugate formula, so you can put some mark here or notes here. A squared minus b squared equals a plus b times a minus b. All right, that's x plus 3, x minus 3. Let's solve the x-intercept. This equals 0, this is 0, this is 0. We have 3 equations. X squared equal to 0. X plus 3 is 0. X minus 3 is 0. Let's solve for the x. X is 0. X is -3. X is +3. Let's decide the multiplicity. Multiplicity for the first one is squared. K is 2. Multiplicity here is 1. Multiplicity here is 1. So K is 1. K is 1. For the K equals 2, that means touch and bounce off, not go cross. So touch and bounce off. And the second one, go cross. Third one, go cross. Okay, how many? So the x-intercept, that cross. So cross at these 2 points. I can list them in a set notation, -3, 3. Touch means K equals 2. That's even multiplicity, x equals 0. And then let's decide is even or odd. Number 3, even or odd. Let's plug in -x in the function. -x to the 4th minus 9 times -x squared. So negative base and even power, negative base, even power. So we can ignore the negative sign. X to the 4th minus 9x squared. Yay. We have the same expression like the f of x. Look at here. They are the same. That means this is even function. We put even. That means the graph must be symmetrical along the y-axis. Number 4, let's find some point between the key points. So we can plot the key points on the graph. They are 0, -3, +3. So -3, 0, +3. Something between them. Let's try +1 and -1. So let's try -1 first. f of -1 equals -1 to the fourth minus 9 times -1 squared. So we have 1 minus 9, that's -8. -1, -8. And so f of 1, let's try f of 1. 1 to the fourth minus 9 times 1 to the fourth. 1 minus 9, that's -8. You see something? Positive 1, -8. The positive 1 and -1, they all have the same y's value because this is even function. Okay, let's put all the information in the graph. First, the two behavior, both sides is going up. So I put go up. And second, we plot the 3 key points. So at x equals -3, k is 1. So go cross it, go cross it. At 0, we touch and bounce off. Then at 3, we go cross. But we still need to plot the two additional points, -1, -8. For example, this is -8, -1, and here's -8. And then +1 and -8. Okay, so let's connect them. Okay, at x equals -3, go cross, and then touch, bounce, touch it, so not touch it. Let's draw again. So go cross, and then we need to go cross the key points here. At 0, we need to touch and bounce off because the multiplicity is 2. Touch and bounce off, make sure it's symmetric along the y-axis. Touch, and then at the 3, we go cross. Both sides, they are, so two ends, they are all going up. Okay, this is a graph. If you have the